With FE102, we're going to be tracking the firmament. If you ever looked above you in what looks like a dome, you're correct. All the stars are moving once around you every 24 hours, and we see in a spherical field of vision. This is what astronomers would call the celestial sphere, maybe the equatorial grid, and we're going to go over the math around that. For example, how do we know the flat Earth model is correct? Well, the Sunzana lemma is a very good example. It's that figure eight shape, with the smaller north and the larger south. Well, that validates the Gleason map. The Gleason map's not distorted. That's the actual size of the land. And how do we know that? Well, for example, the sun's celestial declination, this is a sky coordinate, nothing to do with the surface. But for example, in December, we know that every year, even without a model, we know this pattern. The sun in December will have a celestial declination of negative 23 degrees. Now, how come the latitude on Earth of the solar zenith, that means looking straight up and the sun's above you, why is that always equal to the celestial declination? So what that means is what I just said, that in December, if the celestial declination is negative 23 degrees, if you go on latitude, so go out on Earth, negative 23 degrees south latitude, look straight up, that's where the sun will pass you. So these simple one-to-one relationships show us that the Earth originally is flat, and that to get a globe, all you do is wrap the real life flat Earth around a ball. So I think once you start tracking the firmament and learning how everything moves, you can be a lot more confident in your abilities to know why you believe in flat Earth, and also to teach other people, explain concepts. And we have a free app. So if you're on Android, it's the Firmament Trackers app. It's a very advanced astronomical system, but it's in 3D. So if you ever seen the other flat Earth apps, they're usually a bird's eye view. So we want you to have the 3D app for free so that you can learn about how the world really works. It's fascinating. So firmamenttrackers.com, or search on the App Store. But we're going to teach you how to use that throughout our lessons. That's kind of the whole purpose. We build the software because we kind of now have an edge up on other institutions. For example, our software can plot multiple observers at once. So, like if you go into Stellarium and use Globe software and turn on the equatorial grid, there's only one observer. They don't let you zoom out to see what the world really looks like, and we do. So when you're tracking the firmament, it gives you an in-depth knowledge of the math behind flat Earth, and how to start now looking up outside, knowing why the stars are rotating. For example, I'm in Belize. My latitude is 17 degrees north. What that means, though, is that Polaris is now 17 degrees north from my horizon, and all the stars are rotating around that. Another one-to-one relationship that proves the Earth must be flat. So FE102 is free. I'm going to be your instructor, and I want to empower you with all this knowledge.